your module 1 will be on elastic property of material. Okay, so we will start with elastic property of material. So what I will do is I will cover few or some part of your unit 1 or module 1, and what I will do is I will cover some part of module. Okay, then we will try to finish module 1, module 2 before your first test. Okay, so today we will start with this module 1, which is nothing but your elastic property of material. Okay, so when it comes to elastic property, I think you already learned this. So I will just explain in a simple way. Okay. So you know rigid bodies. What is a rigid body? With the one which is not movable, okay, which is already fixed. Okay. So what we will do, what I will do is I'll just explain this. Okay. So then we will try to go further in detail. Okay. So if I take rigid body, right? For example, assume your there is a bus, right? So what if there is a bus here? Okay. So I'm not good in drawing, so sorry for that. So this is, and some people, maybe one person is trying to push this bus. Okay. So what happened to this bus if we try to push this? So if it is only one person, he may not have sufficient uh, strength to even move this bus, right? So let us assume there are something like 4 or 5 people. Okay, in that case, what happens? Uh,
Starts moving.
yes, it starts moving. Okay, so uh, this is again using your Newton's law. Okay, so what happens in Newton's law is all of you please mute. Okay, I will ask I will allow you to ask the questions. If not, it is echoing. Okay, so that is the only problem. Okay, fine. So if there are more than 4 or 5 people, then what happens? This may start to move. Okay, if they put a sufficient force. Okay, so this is again using one of your Newton's law. Okay, what is the, so there are 3 laws, and one of them, what it says is it says if you take any rigid body, or if you take any, it will stay in the state of motion or rest until you apply some force. Okay, so that is any in a general body. Okay, so now when I say rigid body, so let us assume I'm instead of bus, I am taking a wall. Okay, so this is a wall. The wall is fixed to the ground. So let us assume it is very strong concrete wall. Okay, so or just a pillar. So now even if some 5 6 people try to move this, what happens? Can they move it? So it's difficult to move them, move this, right? Nothing will happen to uh, this wall. Okay, if it is very strong and if it is having very nice base. Okay, so if it is very well well inside the ground, and if it is uh, very much in contact with the ground, then what happens? It won't move. But instead of some person, so if I use some JCB or some other bigger instruments, okay, like a JCB or even bigger, then what happens? If I put force here, so what will happen to this wall? So it will try to be there for, or it will try to remain in its position for some time, okay, and then what happens after some large force, what happens? This will break and it will fall, right? So this is called as a rigid body. Okay, rigid body means which is already fixed to some support. Okay, or it is very strongly having some support. Okay, so this is wall. So what happens is it breaks. So instead of wall, if I use some very thick rubber, okay, so wall is made of in the first case it was made of concrete. So here it is concrete. So here I'm taking the same wall, but or same pillar with rubber. Even if you apply some strong force, what will happen is it will just displace, right? So it will just try to displace in like so it will come to this position. So after some force, okay, so it has to come. Sorry. So it will come to this new position, and as you remove the force, then what happens? It will try to come back to its original position. Okay. So if you take the same cross section based on the material, okay, here you had and then here you have rubber, right? So based on the material, what happens is you have two different properties here. Okay, this is what we call as the elasticity. Okay, so elasticity, there are two things. Okay, the first one is plastic, and the second one is your elastic. Okay, so for example, in case of your concrete is plastic. It doesn't has any elastic property, and then elastic, if you take the second one, rubber is elastic. Okay, so then how do you define this elasticity? Elasticity is nothing but it is a property of a given material to undergo deformation and then to uh, regain its original shape or size. Okay, so if you take plastic, what happens to in case of plastic is, so if you once you apply the so this force, whatever you are applying, so that will be called as sorry, so if you take the force, so this force, so for example, here if you take the JCB, we call it as deformation. Okay, deforming force. Okay, so what is the meaning of deforming force? You know, form. Okay, form is nothing but it is having some shape and size. Okay, so this has a shape and size. So it has some shape and size. What you're trying to do here in this case is you're trying to apply some force, and then you are trying to change the shape and size. So this is why it is called as deform. Okay, deform is you have to change the its shape and size. Deforming force, whatever external force, we call it as deforming so force. Okay, so in some textbook they will use this word. Okay, so this is nothing but it is a external force. Deforming force is nothing but it is the external force. So now you're trying to deform. Deform means you're trying to change the shape and size by applying some external force. Okay, it can be any kind of force. It can be mechanical force. It can be your what is it, pressure. You can even apply pressure and all those things. Okay, so it can be any force which is nothing but it is a deforming force. Okay, so what happens in case of plastic materials is when you apply a deforming force, the material will not regain its original form or original shape. So that is nothing but your plastic. Okay, that is the plastic nature of the material. And if you take elastic means in case of elastic, what happens is you can when you even after removing the force, what happens, the material will try to come back to its original shape and size. Okay, so you can give some example for plastic. So you can unmute yourself. You try to tell me what are the plastic materials. So
Polythene.
Poly
Polythene.
polythene. Okay, and then
Nylon.
PVC.
PVC pipe.
Nylon.
Metal. Which metal? So someone told metal. So
Podium.
which metal? Podium. Okay. So even if you take, for example, even if you take, so let us have things. Okay, one is your plastic. Okay, first one I will write as plastic. Okay, so you told someone told PVC, then polythene. Okay, polythene, I don't know, because sometimes you can also regain if you don't put too much pressure. Sometimes it can come back to original shape. Okay, so what else? PVC, polythene, then
Nylon.
nylon. Okay, nylon. But nylon, you can, I think, you can come back, right? If you put some low pressure, and then there is a possibility that it will regain its shape. Okay, but there will be some kind of deformation. But we'll come to that. Okay, what is the meaning of deformation? Okay, so then what? So if you take your mud, okay, for example, your mud, and you know putty. What is a putty? So this is the layer that they apply after your bricks. Okay, so after your brick and cement, they put some small layer called as putty. Okay, so this is also one of the one of your plastic material. Okay, plastic itself is a plastic material. Okay, but still plastic will have some kind of elastic nature. So, because if you take your plastic scale, if you try to bend it, and if you don't push too much pressure, then what happens? It will go back to its original shape, right? If you put too much pressure, then there is a possibility to break the plastic scale, right? So this is why when it comes to your plastic, when you give example, try to give something like putty or something like mud. Okay, so they are good example for your plastic materials. So when you come to your elastic material, what are can you give some example for elastic?
Rubber.
Rubber, quartz. Okay, so someone told quartz is good. So you know what is the or which is a good elastic material? It is quartz. Okay, I think I wrote something wrong now. QUAR is okay, quartz. Quartz is a form of glass. So someone, yeah, you can tell. What is that? Next one. Uh, what are the other things? Someone told metal, right? Metal is steel. Steel is also kind of alloy, okay, right? It is a metal, and you can take also even some other metals, okay. You take metals, for example, they will be having some elasticity, okay. So it depends on each metal. So it is not like 100% elastic, okay. Uh, so why you need to sorry. So why you need to study all these properties of a given material? Okay, why you want to know what is the elastic nature, what is the plastic nature? So this is so let me take on your for example, let me take your mechanical. Okay, so even in case of your mechanical, if you want to build a machine, right? So if you want to build a machine, then you need what kind of material you need to choose, right? You cannot choose just take some arbitrary metal and you cannot do it, right? So if you take even in metals, in case of metal, if you want to build a high pressure some vessel, example, okay? So if you want to take if you want to build a high pressure vessel, then what happens? It is not feasible to do some with some steel or something like that. Okay, you need to take a very high what is it material, maybe like a titanium, right? You may be using some what is it hydraulic press. So when you are using a hydraulic press, you cannot make a hydraulic press using some aluminum. If you use it, if you use aluminum, what happens is it will not withstand those forces that you apply, right? So if you so these are the things that you need to know. Why? So the elasticity plays very important role when you want to choose a material application. Okay, so that is why we are going to study this kind of elasticity in your class. Okay, so it is again very much applicable for your branches and in your future work. Okay, so then you know between the plastic and elastic, right? So now what we'll do is so you need to also remember deforming force. What is deforming force? Okay, deforming force is nothing but it is the external force which you apply, okay, to change the shape of the uh, your material. So now we'll go to the next one. Okay, so these three things, so you need to know the difference between these three things. One is your load, and then strain and stress. Okay, so can anyone tell what is the difference between load and stress? You can unmute yourself. So, for example, if you want to, what is the difference between your load and the stress? So, yeah, if I take the load, okay, so I will explain it. Okay, so if you take the load is nothing but it's a external applied force. Okay, whatever your force you are applying. In case of in the previous case, I told I am applying by from a JCB, or I am asking some four people to push it. Okay, so this force is nothing but it is a applied force, external force. So that is what we call as load. Okay, Then what is the stress? So pushing your so I will come back to your this one. Okay. So if you when you're pushing, for example, I will take rubber. Okay. When we're trying to push the rubber, so what happens to this rubber is it will also have some force or the opposing force. Okay. Rubber is going to have some opposing force, because if I'm trying to push this rubber, I will also have some force. Okay. I will experience a force. This force is nothing but the force of the rubber. Okay, this is the force offered by the rubber. So this is what we call as stress. Okay, stress is nothing but it is the internal restoring force. What is the meaning of restoring force? Is your rubber is trying to come back to its original shape or size, right? So that is nothing but your restoring force. Okay, the internal restoring force of the material per unit area. Okay, so this we will write it as F by A. Okay, so F by A is your restoring force. So F is the external applied field, and then force, and then A is the area of cross section. Okay. So normally your SI unit will be Newton per meter square, or it can be also. Okay. So you can use Newton per meter square or Pascal. Okay. So this is your stress. Then what is the strain? Strain is nothing but whatever change occurs for the given material. Okay. So I told this rubber is pushed like this. So it may come back to the same position, or what happens if I remove the force? Once I remove the force, it may just come and sit here, right? So it is not the same position. So there is a so this was the black one is the original position, but now what there is a displacement here, right? Because this is something called as there is a deformation in the material. Okay, so when you have some this kind of change, this is called as strain. Strain is nothing but it's the effect of your external force on the size shape of the material. Okay, so this we call it as your strain. So how do you define the strain? Is ratio of change in dimension to the original dimension. Okay, so as you're taking change in dimension, right? So change in dimension is is a change in dimension to original dimensions. For example, if I tell change in length delta L divided by L. Okay, so in that case, what happens? Change in length will be in meters, for example. Okay, or centimeter, millimeter, whatever it is. Then length is in meter. Okay, so then what happens? These two will cancel. So it is a dimensionless dimensionless quantity. Dimensionless means it has no unit. Okay, and there is no dimension for that. It is just a number. Okay, strain is just a number, but in case of your stress, it is a dimension quantity because it's Newton per meter square. Okay, so you need to know these three things. So I normally what I do is I'll just give a very simple example. Load. If we take our daily life, what is load is? Load is okay. So tomorrow you will have a quiz, or I will tell okay next week you have 5 class. Out of that 5 class, I will give you a surprise quiz. Okay, I don't tell when is the quiz. I will tell okay you will have some quiz. So what I am going to do is I'll keep teaching, and then I ask you to write a quiz. Okay. So I will teach for 15 minutes, then I will tell, okay, you guys write the quiz. So what happened to that? So if you are prepared, is fine. But if you are not prepared, then what happens? This becomes a load. Okay, load is nothing but it is the external pressure. Who is external pressure? I am putting the external pressure, right? Then what happens normally? What is the stress? Stress. How do you get the stress? Your mind will be telling, no, I will not write. I will not write test today, right? Or I will not write the quiz today because I score well. I am not prepared. Okay, that is the stress. And what is the strain? Once you write without preparation, you get less marks. That is the strain. Okay, so this is how you need to know. Okay, so the load is always external. Okay, so sometimes what happens? People will get confused with these two things. Okay, stress and load. Stress is different. Load is different. Okay, load is the external force that you apply. Okay, whatever force you apply to the material, that is the load. Then what is the stress? Stress is the internal restoring force. So this force is kept within the body of that material. Okay, if I'm applying a load on a rubber, then this force is developed by the rubber or inside the rubber. If I'm applying the same load on your stainless steel, what happens? This stress will be developed within the stainless steel. Okay, So this is the internal force. Okay, so you need to be careful with these two things. Okay, then what happens? The strain is the resulting thing. Okay, so if you have some change, ratio, if you have change in length or change in volume, then it is called, it is nothing but your strain. Okay, so this is a resulting of your load. Okay, whatever your applied load is. So once you remove the load, then you need to see whether your is coming back to the same position or not, or whether it is having the same shape or not. Okay, and if there is any change in the shape and the size, then we call there is a strain in the material. Okay, so these are the three things that you need to remember. Okay, so then what happens is, again, what we will do is, uh, we will take these each of them separately. Okay, I will take stress and strain separately, and then we will have classify different types of stress. Okay, so this is very general classification. This is not what you call as a universal classification. Okay, so this is very basic classification that I am going to talk. Okay, because if you take stress, there are so many other things. Okay, so we are not going to talk on all the kind of stresses, but here is I will restrict myself very basic things. Okay, so the stress, whatever you apply, it can be three types. Okay, one is your longitudinal linear stress, and then the second one is tangential or shearing stress, and the last one is your volume or your bulk stress. Okay, so what is the meaning of your okay, so let me come here. Okay, so what is the meaning of your longitudinal stress? Okay, so in simple words, you have I will just tell you that so I have three things, right? So I have longitude, right? Then I have your the second one is nothing but it is your shear. Okay, or sometimes it is also called as tangential. Okay, and then last one is your volume. Okay, so this I will just in simple words, what I will do is I will call this as something like 1D, then 2D and 3D. Okay, so I will tell what is this 1D, 2D, 3D. This is just for your simple explanation. Okay, it is not like this is very a proper way of telling it. Just to make you understand, I'm going to give this kind of example. Okay, this is 1D, 2D, and 3D. Why you call this as 1D? Why you call it as 2D, and why you call it as 3D? Okay, so when you take longitudinal, 1D means there will be change in only one dimension. Okay, so if I want to explain or if I want to give a description of any physical quantity, for example, if I want to tell what is your physical description, normally what you say is I am 5 feet tall. Okay, I am maybe 1 feet wide, and then maybe 3/4 feet of thickness, right? So this is nothing but if you want to describe any object, you need three dimensions. Okay, length, breadth, and height. Same thing. If I want to tell, okay, so I told this is a concrete wall or concrete pillar. If I want to tell what is a, if I want to describe a pillar, what I need to tell is I need to give the what is the height of the pillar and what is the thickness of the pillar. Okay, and then what is the width of the pillar. Then only I can tell, okay, you can build this pillar, right? So in the same way, so if you want to take, if you take any at least three dimensions or three variables to describe this physical appearance. Okay, so now when it comes to longitudinal, I told it is 1D, and then shearing I told 2D, and then volume I told 3D. Okay, so tell what is this, what is the meaning of this. Okay, so if I take stress, for example, so what I will do is I will take a rubber tube. Okay, so or rubber tube or anything, or even it can be a stainless steel, and I will fix this. It is fixed. Then what I will do is I will apply the load. Load means I can just put some weight on the this end. Okay, if it is rubber, then what happens? Initially it was at this position. Okay, so this is the original position. Then once you apply Okay, if you, once you apply the load, what will happen to that? So this will try to extend a little bit, right? So it may come here. So after load. So this is after. Okay. So after load, what happens? It will come try to come here. So that is how you have change in the length. Okay. So now this is not the actual change in length, but okay. So once you apply the load, this length is going to extend. So if I take this is my L, okay, from this L, then there will be small change in delta L. Okay, so or this is I'll just tell, okay, this is L plus delta L, something like that. Okay, L plus some maybe some value. Okay, so for example, if I take this is like 1 meter. Okay, so if I tell this is 1 meter, then what happens after applying the load? It may go to 1.3 meters, right? So now this what is happening is only one of the dimension is changing. So let us take this wire is almost very small. Very small means maybe I will tell. So if it is 1 meter, I will call this is like 0.5 centimeter. Okay, 0.5 centimeter is almost negligible when compared to 1 meter. Okay, so in this case, what happens? If you take the change in the length, it will be very high compared to the diameter. Okay, so the diameter will be less or the thickness will be very less, the change. Okay, so because here it is 0.3 meters, maybe the change in the diameter may be 0.1 or 0.01 centimeter. Okay, so it will be very less. So in that case, we can ignore the or we can neglect the change in its diameter. But when it comes to the length, there is a considerable amount of change. So that is why I called it as 1D. Okay, so 1D means there is a significant change in the one of its dimension. Okay, so instead of all the dimension, only one of the dimension is having significant change. Okay, so this is called as longitudinal stress. Okay, that means your force is only in one dimension. Okay, so now what happens is I will take the second case. So for second case, what I will do is I will take some block. Okay, so this is a block. Best example is I will take some rubber block, and so this is fixed in one end. Okay, so this is fixed. Now what I will do is I will apply force on top layer. So if I apply the force here, so this is my force. So you are trying to push one of the layer. So the layer will not move because it is already fixed. So if this is a rubber, why I'm telling rubber is it is easy to visualize. Okay, but it can also be some metal. Okay, it need not be always your rubber. So now what happens once you apply the force, so this point will be at the same position, but the top layer is going to move here. Okay, so something like this. So this point is coming to this point, and then this point is coming here. Okay, so in the same way, if I take this point, it will move to some other point in the direction of applied force. Okay, so this is now your new block. Okay, so let us assume it is within the elastic limit or within the it has not broken. Okay, in the same way, what happens? The bottom layer will not move. So this is fixed. Okay, so these things are fixed. So there will be no change. So this is after applying the force. So as there is change in two things, the length is changing and also the width is changing. Okay, so in this case, what happens? There is change in two dimensions. Okay, so this is what we call as your tangential because it is creating some angle here, theta. Okay, so this is your theta. So let us assume it is this height. Okay, then this displacement we can take delta L. Okay, so or W, W or L, whatever you want. Okay, the change if I take this is width is if I call this is a width W, happens with the change in width will be delta W. Okay, a small change. So similarly here I wrote delta L. Delta L is the small change in the length. Okay, so this is what we call as shearing or tangential stress. Stress is it is the external applied force. Okay, so you need to be careful with this. Okay, I'm only talking about the stress right now. Okay, so you are applying some force. So this force will become a tangential force. Okay, but how do you define this tangential force? So if you take your stress, So I told stress is nothing but it is, so in the previous one it is force by area, right? So in this case, so now when I tell about longitudinal stress, so this is again, how do you define this is, it is still F by A. Okay, so if you take your stress will be F by A. But in the first case, what happens is it is one dimensional force. That means there is change only in the length. Okay, so in the second case, what happens? Second case, you are having change in both width and your length. Area will be two dimensional. Okay, here the area is only one dimensional because we are taking only length to be changing. Okay, so in the same way, I can also write something for your volumetric change. Okay, volumetric change or bulk. Okay, so some people they use it as bulk, or some people they use it as volume. Okay, so both are same, bulk or volume. So both are having the same meaning. Okay, bulk stress or volume stress. So what is this bulk or volume stress? So if I take some ball, okay, so I'm going to take your football, or maybe your basketball. Okay, then what I'm going to do is I will apply pressure from all the sides. That means I'll just hold the ball, I'll try to squeeze this. Okay, so if I apply the force from all the sides, then what happens? So this is going to shrink a little bit, right? So this is the original, the red one is the original size. So then what happens if I apply the force? Then this ball may become, I think okay, so the shape of the ball will change to this one. Okay, so it has shrunk in volume. Okay, so this is what we call as bulk or stress. Okay, so this means there is change in 3 dimension. Okay, so in the first case there is only change in 1 dimension. There is, in the second case there is a change in 2 dimension. In the third one there is a change in 3 dimensions. Okay, if I take ball, it is circular, but instead of, so come back to this PowerPoint. Okay, so in this case, if I this is the same thing is shown here. Okay, longitudinal or linear strain. Okay, so linear means it is in 1 dimension. So what happens is when you apply the stress in 1 dimension, so this has to be stress. Okay, so I think this is wrong. So this is a longitudinal strain. This means there is force in 1 dimension. Okay, there is only the force in the length. Okay, when you take the tangential or shear stress, what happens is there is change, the force has changed 2 dimensions. Okay, so one is the length and then the width. Okay, the last one, what happens, as I gave example for your football or your basketball, this volume is changing, so we call it as volume stress. Okay, or even if I take some cube, then if I apply force from all the sides, okay, so I need to apply all 6, it has to be uniform force. I cannot apply more force here, less force here. Then what happens? It will have deformation. Okay, uneven deformation. Let us assume it is a uniform force. Okay, on all the 6 sides. Then what happens? This is going to change the shape. Okay, the solid line is the original size, and then the dotted line shows the change in the size. Okay, so once you apply a uniform force from all the 6 sides, then what happens? There is a contraction in the in your in the shape, okay, or in the size. The same thing can be for outward. So I told inward, but it can also be outward. So I take a ball, then what I do is I'll fix some what is it, support, and I pull it out. If I try to pull it out, then what happens? It will make a new circle. So something like this. Okay, so this is your new circle. So in this case, what happens? There is a increase in the volume. Okay, so this is in the first case, there is a change in volume as minus delta V because it is shrinking. The volume is decreasing. Okay, but in this case, what happens? It will be V naught plus delta V because it is increasing. Okay, so there is increment. It can be or it can be decremental. It can be both. Okay, but only thing is it has to be only within its limit. So there is some limit, because if you try to pull too much, then what happens? Your ball may get damaged permanently. Okay. So within the limit happens, you can have this kind of three kinds of stress. Okay. The first one is longitudinal stress. The second one is tangential stress, and the last one is your bulk or volume stress. Okay. So these are the three things. I think you have already learned of in the previously in in your previous classes. So I'm not going to go in detail. So I'll just have to recapitulate, or maybe just to refresh you all these things. Okay. So just I'm trying to do that. Okay. Next is we'll go for the next one. What is the next one? So we talked about the stress. So now we will see the strain. Okay. So the same, like if we have a longitudinal stress, then what happens? There will be longitudinal strain. In the same way, if I apply a shearing stress, then what happens? This will result in shearing strain. And then if I apply the bulk or volume stress, then this will result in your bulk strain. Okay. So these things we are going to see. Okay. So stress and strain are again related to with each other. Okay. So each one is related with each other. Okay. So these are related with each other. So for every stress there will be corresponding strain. Okay. So that is nothing but your change in your dimension. Okay. So now we will see what are the three strain. Okay. The first one is your longitudinal strain or linear strain. Okay, of longitudinal or linear strain. So in the previous case, we wrote this is force by area, right? So your stress is force by area, but when it comes to your strain, strain is change in dimension to original dimension, right? So in the first case, what happens is if I take first one, this will be change in length. Okay. So I will write change in, and then I will okay, change in by original. Okay. So in the first case we are having only effect on the your length. So in the first case, what happens? This is change in length by original length. Okay. So change in length by original length. So in the second case, what happens? It is two dimensional. Okay. So when you have two dimensional, then what happens to your change? Change is nothing but we call it as theta. Okay? Your you can see here, this is your theta. Theta is nothing but it is a change in the angle. So normally you can define it as tan theta. Okay. So if you take from this from your this triangle. Okay. So if I as a triangle. Okay, so if I call this is A, then this is B, then this is B dash. So if I take the triangle A, B, B dash, then it is theta is you need to give the tan theta. Okay. So normally tan theta, but you won't write it as tan theta. We'll just take it as theta because theta is very, very small. Okay. So in that case, what happens is your theta will be your shear angle. Okay. Shear angle is your shear stress, sorry, shear strain. Shear strain will be theta is equal to your, how do you define your tan theta? Tan theta is opposite by your adjacent. So it will be your, if I call this is the change is delta W, or I will write BB dash by your AB. Okay. So then what happens? This theta will be equal to your delta W in the diagram. Okay. Delta W by H. Okay. So H is the height. So then I will call this H is the height. So I can write this as BP dash by AB, which is nothing but delta W by H. So that is shearing strain. Okay. Shearing strain is defined in this form. Okay. So then when it comes to your final one, what is the final one? Your volume strain. So how do you define volume strain? Volume strain is nothing but it is change in volume by original volume. Okay. So this change in volume divided by original volume. Okay. So that is how you define this is your strain, okay, volume strain. So how do you define the stress? Stress is again still force by area, okay. So in the 3D, what happens is you have to take area is your entire three-dimensional surface, your wall. For example, if you take a cube, then it is V cube, okay, or A cube. If I tell A is length of your cube, then it is having all lengths are same. For example, if this is a cube, then if I want to say what is the force, force is F by A or F by volume, because it is three dimension, okay. So if I tell this is having a length of A, and if it is cube means all sides are same, so F by A cube. Okay, so that will be the force for volume stress. Okay, then when you come to the shearing, sorry, volume or bulk strain, when you say the strain means it is change in dimension to the original dimension. So in that case, what happens is it is change in volume by original volume. Okay, so shearing strain is nothing but theta. Theta is nothing but it is delta W by H. So whatever you have in that diagram. Okay, so is it clear? If you have any doubt, you can ask. Do you have any doubt? Are you still listening?
No, sir.
Okay. So then it's fine. Actually, this is very basic thing. So I'm not going to stress it again. But you need these things. Okay. So
More like a pizza. More like a pizza.
okay. So I'm not going to stress it again because it's almost very common one. Okay. So then I will just recap it. Okay, whatever we learned today, we'll recap it. Okay, then I think I will stop it because maybe next you need you have to go to the next class. Okay, so you have to log into other class. So I will just recap this whatever we learned. Okay, so if you take any material, then what happens? There are based on their properties, we can have either plastic or elastic. Okay, so when it comes to plastic, then what happens in plastic material? There is a permanent deformation of the shape, okay, or once you apply the external force or deforming force, then what happens? There is a permanent damage. So for example, your plastic is like mud, putty, and PVC, all these things, okay. So these are plastic materials. And when it comes to elastic material, what happens is so even after removing the deforming force, what happens? The material will gain its original shape and size. So that is your plastic nature of the material. Okay. So example is quartz, rubber, steel, metals. Okay. So I won't tell all the metals, but most of the metals. Okay. So most of the metals, they are elastic. So even if you take aluminum, you can bend the aluminum and then sometimes it can go back. Okay. So stainless steel, the same thing. You can bend the stainless steel. So after that, what happens? It is going to come back to its original. Maybe there is maybe some small change. Okay. So plastic and elastic materials. Then you have three kinds of things. So what is that? You have load, stress, and strain. So what is load? Load is the external applied force, or you can also call it as deforming force. Okay, your deforming force is your load. Load is nothing but it is the external applied force. Then what is stress? Stress is the internal restoring force that is developed within the material. Okay, so this is a force per unit area, and then its unit is Newton per meter square or Pascal. So this is your this force is developed within the material. It is not an external force, but it is developed within the material or by the material. Then what is the strain? Strain is resulting of your load and stress. Okay. So once you remove the load, there is a change in its dimension. Then what happens? It is called as strain. Okay. So it is the ratio of change in dimension to the original dimension. Okay. So next, what we did is based on the kinds of forces to apply. you can have different types of stress. Okay, the first one is longitudinal or linear stress. Next one is your shear or your tangential stress. Last one is bulk or volume stress. So correspondingly, you have a strain three types, which is one is longitudinal strain, and then shear strain and bulk strain. Okay, so I think I didn't explain one thing. What that is nothing but, so here, what is the meaning of change in length? Okay, change in length is, so I told I am taking 1 meter long wire, then I am trying to stretch it to 1.3, and if I remove the wire, if I remove the load, then what happens? Your material may not come to its original size, but it may have some kind of deformation. Okay, so this is what change in the length. Okay, so for example, this may be, instead of 1 meter, this may be 1.05 meter. Okay, so if it's 1.05 meter, then what happens? There is a change of 0.5 meters. This is what we call as change in length. Okay, so the change in length to the original length. Original length is 1. So 0.5 by 1. So that will be your longitudinal strain. Okay. So that is the change in length by original length. So next, when it comes to shearing strain, it is defined as theta. Okay. It is given by theta, which is nothing but your tan theta. Okay. But we will just write it as theta. That is your shear strain. Shear strain is BB dash by AB, which is delta dW by H from this particular diagram. Okay. In some examples, what they do is they will call this, instead of W, they will call it as L. Then this is delta L by H. Okay, so that depends on what you name it. Okay, you don't have to name it as I teach or as it is in the textbook. You need to just explain it. Okay, W means it is the width, and then delta W means it is a change in the width. Okay, so those things you need to change, right? Next one is nothing but it is the volume or bulk strain. Volume or bulk strain is defined as change in volume by original volume. Okay, so whether it is longitudinal strain, shear strain, or strain, it is a dimensionless quantity because it is having no dimension. Okay, so this is what it is written here in this one. Okay, so it is dimensionless because even if we take change in length m by m, it is cancelling. In the second case, it will m square by m square, so it will cancel. In the last one, volume is a cube. A cube means it is meter cube. Meter cube by meter cube, again it is going to cancel out. Okay, so in all the cases, this strain is going to be remain as dimensionless. Okay, there is no dimension. So if you don't have any doubt, I think we will stop at this point, and then I will continue tomorrow. Okay, you can if you have doubt, you can ask. If not, you can leave. Okay. So if you have a doubt, ask me. If not, we will see tomorrow. Okay. So tomorrow you have class again at 9. I will send you the link. It is the same link. Okay. So for physics, you can keep the same link. Still, I will send you again. Okay. Helpa.
Sir, notes. So.
Notes, I will send you. Okay, don't worry. I will send you the soft copy. Okay. I think you received syllabus copy yesterday. So I think okay. So I will send you the notes. Don't worry. Okay, I will send you the notes. I'm trying if I can textbook. Okay, if I get a soft copy of textbook, I will send the soft copy of textbook. But I will definitely send the notes. Okay, I will send you the notes. No problem. ಬ್ರೇಕ್ ಭಾವನಾ ಬ್ರೇಕ್ ಆಗ್ತಿದೆಪ್ಪ. ನಿಂದು ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ. You can ask. You are asking something. ವಾಟ್ಸಪ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ನಾನಿಲ್ಲ. ಯಾರು ವಾಟ್ಸಪ್ ಗ್ರೂಪ್ ಅಡ್ಮಿನ್ ನನ್ನನ್ನು ಆಡ್ ಮಾಡ್ತೀರಾ? ನನ್ನ ನಂಬರ್ ಇದೆ ನೋಡಿಪ್ಪ. ಸೊ ಅಡ್ಮಿನ್, ಯು ಪ್ಲೀಸ್ ಆಡ್ ಮೈ ನಂಬರ್. ಓಕೆ, 94. ಐ ವಿಲ್ ರೈಟ್ ಹಿಯರ್. ಓಕೆ, ವಾಟ್ಸಪ್ ಗ್ರೂಪ್ ನಾನು ಮಾಡಿಲ್ಲ. ಸೊ ನಿಮ್ದು ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಎ ಸೆಕ್ಷನ್ಗೆ ಏನಾದ್ರು ವಾಟ್ಸಪ್ ಗ್ರೂಪ್ ಮಾಡಿದ್ರೆ ನನ್ನನ್ನು ಆ್ಯಡ್ ಮಾಡಿ, ಆಯ್ತಾ? ಸೊ ನಾನು ಅಥವಾ ನಿಮ್ಮ ಸರ್ಗೆ ಹೇಳಿ, ಹೇಳಿದ್ರೆ ಅವ್ರು ಆ್ಯಡ್ ಮಾಡ್ತಾರೆ. ಸೊ ಅವರು ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ನಾನು ಅಲ್ಲೇ ಹಾಕ್ತೀನಿ ಬೇಕಾರೆ, ಆಯ್ತಾ? ಸೊ ನಾನು ಅದಕ್ಕೆ ನಾನು ಏನ್ ಮಾಡಿದೆ ಅಂದ್ರೆ ಐ ಆಮ್ ಸೆಂಡಿಂಗ್ ಆಲ್ ದ ಲಿಂಕ್ ಟು ಯುವರ್ ಇಮೇಲ್. ಸೊ ನೆನ್ನೆ ಇಮೇಲ್ ಕೊಟ್ಟಿದ್ದೆಲ್ಲ.
Nine numbers are there.
Sir,
ಯಾವ್ದ್ರಲ್ಲಿ?
in number. Sir, 9
Phone
number.
number. 9 number.
ಫೋನ್ ನಂಬರ್ ಸರ್.
9482944 ಇದೆ. ಓಕೆ, 34. ಓಕೆ, ನಾಳೆ ಇನ್ನೊಂದ್ಸರಿ 9482944 ಆಮೇಲೆ 034, ಆಯ್ತಾ? ಸೊ ಆ್ಯಡ್ ಮಾಡಿ, ನಾನು ಅಲ್ಲೇ, ಆಯ್ತಾ?
ಸರ್ ಅಟೆಂಡೆನ್ಸ್.
ಅಟೆಂಡೆನ್ಸ್ ಐ ವಿಲ್ ಗೆಟ್ ಫ್ರಮ್ ವೆಬೆಕ್ಸ್. ನೀವೀಗ ಯಾರ್ಯಾರು ಬಂದಿದ್ದೀರಾ ಅದು ವೆಬೆಕ್ಸ್ ಅಲ್ಲಿ ನನಗೆ ಬರುತ್ತೆ. ಐ ವಿಲ್ ಗೆಟ್ ಇಟ್ ಫ್ರಮ್ ವೆಬೆಕ್ಸ್. ಸಿ ಇಫ್ ಐ
ಮ್ಯಾಥ್ಸ್ ನೋಟ್ಸ್ಗೆ ಅಂತಾನೆ ಸಪ್ರೇಟ್ ಗ್ರೂಪ್ ಮಾಡಿದ್ದಾರೆ, ಆ ಗ್ರೂಪ್ಗೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಸರ್?
ಬೇಡ ಕಣೋ ನಿಮ್ದು, ಅವ್ರು ಮತ್ತೆ ಆಮೇಲೆ ಬೇಜಾರ್ ಮಾಡ್ಕೊಂತಾರೆ. ಆಮೇಲೆ ನಿಮ್ದು ಯಾವ್ದಾದ್ರು ಗ್ರೂಪ್ ಇದೆ ಅದ್ರಲ್ಲಿ ಆ್ಯಡ್ ಮಾಡಿ, ನಾನು ಬರೀ ಲಿಂಕ್ ಕಳ್ಸಕ್ ಅಷ್ಟೇನೆ, ಆಯ್ತಾ? ಸೊ
ಓಕೆ ಸರ್.
ಓಕೆ
ಸರ್ ಕ್ಲಾಸ್ ಹಾಕಿ ಸರ್.
ಏನ್ಪಾ?
ಕ್ಲಾಸಸ್ ಮುಗಿದ್ಮೇಲೆ